So, what if the fundamental rules of our universe, the cosmic constants, aren't just a random bunch of numbers? What if they're actually frozen fossils from the very first moment of creation? Today, we're diving into a pretty radical new way of thinking that could honestly change how we see everything. To really get our heads around this, we have to start with one of physics' biggest secrets. Our reality is basically built on a handful of magic numbers. These are the cosmic constants. They're the values that define, well, everything, from how fast light travels to how strong gravity is. But the big question has always been, where in the world did they come from?
Okay, take the fine structure constant. It's this pure number that decides how light and matter interact, and its value is just sitting there at roughly 1 over 137. It has no units, there's no real explanation for it, it just is. And for a physicist, that is a deeply, deeply unsettling mystery.
And here's the real kicker. If you were to change that number or any of the other constants by even the tiniest little fraction, the universe as we know it, with stars and planets and us, it just wouldn't exist. So are we just incredibly lucky? Or is there something much deeper going on here? Well, a new framework is proposing a single, really powerful answer. And it starts by throwing out our most basic assumption about what space even is. It suggests that all of reality is simply a behavior, a kind of vibration in the fabric of the cosmos itself.
This idea completely flips our understanding of space on its head. You see, instead of thinking of space as this empty, passive container where the universe happens, you have to imagine space as this vibrant, active substance, a self-oscillating medium that is reality itself. Space isn't the stage, it's the play.
The core of this whole idea is something called space-time phase. The best way to think about it is like a perfectly still lake. Every ripple, every wave, every whirlpool is a different behavior. That's our matter, our energy, our forces, but it's all just patterns in the same underlying water. This framework is suggesting that's what reality is, one single synchronized oscillation. Okay, so if everything is just a vibration, how do we get this solid stuff that we can actually, touch? This is where it gets truly brilliant. The framework explains both energy and matter as just two different behaviors of the exact same medium. First up, you've got energy. When this space-time medium vibrates freely, kind of like a ripple spreading across a pond, we perceive that as energy. A photon of light, it's just a free vibration traveling through the fabric of reality. Pretty simple, right?
But what happens when that exact same vibration gets trapped? When it twists back on itself into a stable, standing wave? Basically, a knot in the fabric of space-time. Well, that self-trapped vibration is what we call matter. Mass is simply vibration that can't escape. It's geometry recycled into itself.
And this brings us to a conclusion that is just mind-bending. In this view, an electron isn't some tiny little thing. It's a stable, geometric scar in spacetime, a persistent knot in the cosmic vibration. Matter isn't a substance, it's a shape. Which, of course, begs the question, where did all these knots come from in the first place? In this framework, the Big Bang wasn't an explosion in space. It was a phase transition of space. It was the moment that the fundamental rules of our universe literally froze into place. So how did this actually happen? Well, it all starts in a state of perfect symmetry, just a single, uniform, timeless oscillation. Then, in an instant, that perfect coherence fractured. Space-time fell out of sync with itself, and in that one moment, the rules of our universe, the geometry, time, and matter, locked in. So let's bring it back. What does this all have to do with those magic numbers we started with? Well, if the Big Bang was a phase fracture, then the cosmic constants aren't random at all. They are the measurable, leftover properties of spacetime's broken symmetry. They're cosmic fossils from that very first moment. And this is where it all just clicks together. The speed of light isn't just some cosmic speed limit. It's a measure of how stiff space-time is. It's the fastest a ripple can possibly travel through it. Gravity isn't some mysterious force. It's a measure of space-time's elasticity, how much it can give or bend. Planck's constant is the smallest possible twist space-time can even handle. And dark energy? That's the leftover tension from that original fracture, still trying to smooth itself out after all this time.
So you see, the universe doesn't appear fine-tuned for us because of some miracle or because we're in one lucky universe out of a trillion. It's because only certain geometric ratios, these constants, allow for stable, self-locked knots to form in the first place. The constants aren't tuned for us. They are the fundamental conditions that are required for any structure to exist at all.
So, what's the big takeaway here? It means the universe isn't just a collection of different things, but a single interconnected object that's defined by its own geometry. And that leaves us with a really profound final question. If matter is just one way for spacetime to tie itself in a knot, what other stable geometries are out there just waiting to be discovered? What else can reality become?